Okay, so this is the Excel sheet in which we are going to perform the simulation. So to begin, let us first put down the column headers. So the first column will be the experiment, and the remaining columns will be for the respective 5 coin tosses. So toss 1, toss 2, toss 3, toss 4, and toss 5. Now we are going to put down the numbers 1, 2, 3, 4, 5, 6, right up to 10,000, because we are going to simulate 10,000 experiments. And so we begin by typing 1 here. Then we go to the next cell. We type in the formula. And so this cell should be equal to 1 plus the value in the previous cell. So that gives us the value 2. And we are supposed to fill in 3, 4, 5, 6, and so on. But then there is a quicker way of doing it. Now this is column B, and the numbers are starting with row number 3. So the 10,000th experiment is supposed to appear in 10,002th cell, right? And so when you press enter, it takes you to the 10,000th cell on this column. And here we can type in anything that we want with the up arrow and control. We go to this particular cell. With control C, we copy the formula, and with control shift and down arrow, we go right at the end of this column, and then we control V to paste the formula. And now you can see that this whole column has been populated with numbers 1 to 10,000. Now we are going to simulate the coin tosses. Now, let's say we are having a fair coin to begin with. And so the way we are going to simulate one coin toss with a fair coin is to say equal to rand between. In fact, we have to use an if statement. So we say if rand between 0, comma 1 uh, is equal to 0, then we consider that we have got heads, else we consider that we have got tails. And when you press enter, there you are, you get the outcome for the first coin toss. And then getting the other 4 coin toss is very simple. You just got to copy the formula over here and then paste it across, and then say control V to paste the formula. Right. So now it turns out that all the coin tosses over here have turned out to be heads. Well, that would be a very rare occasion, but nonetheless it can happen. And so if you press the F9 button over here, then you will realize that the formula gets recalculated as many times as you press the F9. Now, what you have just now done in this particular row over here is simulated one experiment. But then we are here to simulate 10,000 experiments, right? Again, this should not be taking a very long time. We just type in something across these 4 cells or 5 cells, and then you just go over to the top, copy the formula over here with Control C, with Control Shift and bottom arrow. You go to the last row of this particular table, and then with Control V you paste the formula, and so there you are. So what you have been quickly able to do is simulate 10,000 experiments, and in each of these 10,000 experiments the coin has been tossed 5 times, and you have got all the outputs. So 10,000 experiments, and in each experiment there are 5 coin tosses, which means you have actually tossed this coin 50,000 times, and it hardly took about a minute to do so. Right. So now what we are now going to do is we will also have to figure out the number of successes in each experiment. And here we are going to consider heads as success. All right. So here we are going to introduce another column header, and we are going to name this column as S for the number of successes in each of these experiments. So what will be entered here in this particular cell is the number of successes that we have gotten in this experiment, right? Uh, Meaning the number of heads that we have gotten in this particular experiment. And in order to do so, we use this formula COUNTIF. COUNTIF, uh, we have to give the range across which we are figuring out how many heads are there. So this is the range, and that should be followed by what is it that you are looking for, and we are looking for heads over here. All right, so when you press enter, it will tell you that there are two heads which you have obtained in this experiment. So there is one heads over here and one heads over here, and which means that you have actually calculated the value in this cell correctly. Now, we need the same formula to be executed across all the experiments. So what we now do is go to the bottom of this particular table, type in some random letters over here. We'll go to the top. We will copy the formula with Control C, and with Control Shift and down arrow, we go to the end of this column, and we will paste the formula with Control V. Right. So there you are. So what you have gotten is this column of numbers, which basically contains the number of successes, meaning the number of heads that you have gotten in each of the 10,000 experiments. All right. Now, can you see, if you inspect this particular column, you see that there are occasions where you have got one heads, then will be occasions here where you have got two heads, and you have experiments where you have got four heads and five heads and so on. And rarely you will see, maybe we should be able to find out one such occasion where you have gotten zero heads, meaning zero successes. And by now, it should be very clear to you, if you would have looked at my previous videos, that since the number of coin tosses in each experiment is 5, then this random variable s, which stands for the number of successes that you get with 5 coin tosses, will assume values from 0 to 5. It cannot be less than 0, and obviously it cannot be greater than 5 as well. Okay, so now what we are going to do is we are going to now find out how many number of experiments are there in which we have got zero successes, or how many experiments are there in which we have got one success or two successes and so on. So which means we need to find the frequencies of zeros, ones, twos, threes, fours, and fives in this entire column. And that is again not a very difficult thing to do. So let us again create some sort of a table. Let's say this is the value, this is a variable s, and the possible values of s are 0, 1, 2, 3, 4, and 5. And we are going to compute the number of occasions in which we are getting zero successes here, number of occasions in which we have got one success, and we will fill up this particular column. And let's name this as the frequency. Name this as frequency. Okay, so the way we find out the number of zeros in this particular column is, one way to do it is like use the COUNTIF formula. We can go ahead with COUNTIF. We can give the range, but now we will have to be very careful. Now this column is column H, and the range of the rows is 3 to 10,002. Uh, so which means that we have to fix this particular cell and the last cell in this column. And in order to do that, just writing H3 is not good enough. We will have to say H$3 colon H dollar uh, 10,002, so that this entire column is selected, which provides basically the range of the cells. in which the formula has to figure out how many zeros are there, and you basically say that I want to look for zeros. All right, and then you complete the bracket, and then you see, okay, so there are 316 experiments in which you have basically got zero successes. Now, the way you can fill up this whole column is by being a little smart. Now, here, if you see in this formula, I have typed in 0 over here. But then instead of typing 0, if I would have given the address of this particular cell in which 0 has been entered, I could have simply written it as J3. So let's see what will happen if we replace it with J3. Okay, let's press enter. Uh, well, the number has changed because this particular column has been recalculated. So let's not worry much about that. Now what we can simply do is we can copy the formula over here and then paste it across this entire column. All right. Now, if the entire simulation has gone all right, then what we must be able to verify is that all these frequencies should add up to 10,000. So let's see whether that exactly is happening or not. And we say sum of all these cells, and there you are. We have got exactly 10,000 experiments, and out of these 10,000 experiments, 312 occasions have given us zero successes, meaning none of the 5 coin tosses have yielded heads. Uh, 333 occasions in which you have got all 5 successes, meaning all 5 heads. And you can actually visualize this kind of a frequency distribution by doing a histogram. All right, and the way you would do that is like this. So you basically select the entire cell and use the graphing tools to be able to do that. So let's insert a graph over here. We will use a bar graph, and there you are, and you simply say OK, and then we can beautify the particular graph as per our wish. Okay, so let's tidy it up. Let's put this particular graph over here. Okay, and then we can do some of a few things. So you can see 0, 1, 2, 3, 4, and 5, and all these have, you can see it looks a very nice and a symmetrical distribution with n is equal to 5. N equals 5 means that in every experiment there were 5 trials. And as you can see, in most occasions you would get 2 successes or 3 successes. And on rare occasions, you will get 0 successes and 5 successes. But then for now, we actually don't need this frequency distribution. So I think we will delete this and then do something else. Now, these are the frequencies which have been obtained out of the simulations. And so therefore, based on the data, we can actually compute the probability of getting 0 successes, or probability of getting 1 successes, or 5 successes. And so which means that we can compute the probability of S from the simulated data. And the way to do it is simply by dividing this frequency by 10,000, because we have performed 10,000 experiments. And so there you are. This is the probability value. And we can copy and paste the formula uh, across the length of this column to get the probability values of getting 0 to 5 successes based on the simulated data. Now, if you plot the probability of S versus S, you will get a similar kind of a graph that we had plotted just a while ago. except for the fact that the y-axis will no longer be frequency, but it will actually be the estimated probabilities of getting 0, 1, 2, 3, 4, or 5 successes. Okay. The last thing that we need to do is we should, in principle, verify whether some of the other uh, things associated with binomial probability distribution also hold true from the point of view of the simulated data. Now, we know that the probability of success is, let's say, small p, and the number of trials in each experiment is, let's say, n. We know from theory that the mean of the variable is equal to np. All right. Now, what should be our theoretical mean? The theoretical mean uh, from the given set of conditions should be equal to n times p, and in this case n times p will be 5, which is n, the number of times, equal to 5 times uh, I'm sorry equal to 5 times the success probability. And since it's a fair coin, the probability of success, meaning the probability of getting heads, is 0.5, and so therefore uh, your mean value of S should be 2.5. That's a theoretical mean. But let us find out that as far as our simulated data is concerned, are we getting a mean of 2.5 for this variable S? Uh, so let's look at that. We will say uh, mean estimated from simulated data, and we are going to do this calculation in this particular cell. And the way we simply figure out the mean is by doing an average of all these numbers. Okay, so let's go ahead and do that. We use this average formula for mean in Excel, average, and we basically use this range of cells, complete the bracket, press enter, and then you see you have gotten the mean value from the simulated data to be 2.4978, which is very, very close to the actual theoretical mean, which is 2.5, which means that this particular simulation has gone pretty well. Now you may ask why we are not getting 2.5 to be exact from the simulated data. Well, it will never happen because we are doing this simulation just to pretend as if we are actually doing this experiment using a coin and doing 5 coin tosses across 10,000 experiments. And in a real life situation, uh, you are supposed to get a value which is very close to the theoretical, but you will never get the exact theoretical mean of 2.5. I hope you basically like this video, and maybe more in the near future.